All right, so today we're going to talk about the hypotenuse leg theorem. Basically, on a right triangle, there's the hypotenuse, which is across from the 90-degree angle, and then the other sides we call legs. Now, the hypotenuse leg theorem is basically this. If I have, well, let's just get rid of this. If I have two, oh wow, look at, what? Do you see that? That was pretty cool. I forgot that this does that. I didn't mean to do that. All right. So basically, if I have two triangles and I know a leg, it doesn't matter which leg. If I have two right triangles and I know that a leg is congruent and that the hypotenuse, or the both of the hypotenuses or hypoteni, I don't know what you would say. If those are congruent, then the two triangles are congruent. So let's write this in a little more formal language. If, and let's call this A, B, C, and D, E, F. I'm going to write it down a little smaller down here on the bottom. Let me slide this up a little bit. So what I'm going to say is if AB is congruent to DE and BC is congruent to EF and triangle ABC and triangle DEF are right triangles, then triangle ABC is congruent to triangle DEF. So that is what we call the hypotenuse leg theorem. Now, I'm not quite sure why, but whether you guys realize this or not, it's actually a side-side angle theorem, right? Remember when we covered that side-side angle theorem of congruence? Basically, we have two sides and an angle that are congruent. I don't know why we just don't call it the side-side angle congruence theorem, but it's a right angle triangle and it's convenient for us, and we can use this to prove right angles too sometimes. Actually no, you can't. I take that back. We could use it for an application if we know the triangles are right. So let's get started with example number 1. Did you guys have that all written down? I hope so. If not, let me know. I'll pull it back up, edit the video if we need to. So, for example number 1, what they want us to do is we're going to use this to prove that two triangles are congruent, that two right triangles are congruent. And so, since we are on section 4.6, give me a second to open her up on the book. In the textbook, they have a triangle on a basketball rim. So there's a picture of a triangle on the basketball rim. So basically, on a basketball rim, most of the backboards have a holder that there's like a bracket that holds the backboard in place. And so there's an image of this on in your textbook, but basically, it kind of looks like this. Let me slide that down a little bit. I think my board needs to be calibrated ever so slightly. There we go. Perfect. All right, so now if I label this as they have labeled it in your textbook, we're given A, B, C, and then D, And they want us to prove, basically what we want to do is we want to prove that triangle ADC is congruent to triangle BDC. Now, they give us some given information in the textbook that I'm just going to write down in the proof. I don't want to write it down twice. But basically what they're telling us is that remember, this is our very last step. In that last step, the reason for this is going to be the hypotenuse leg theorem. Okay? So the first thing they tell us in the textbook is that angle ADC is congruent to angle BDC, right? And, or not congruent, I'm sorry. That's not congruent. What they tell us is that those angles, ADC and BDC, those are right angles. So now what that means, let me show you what that means. That means that this is a 90-degree angle and this is a 90-degree angle. Okay? And then they tell us that AC is congruent to BC. And this is given as well. I wrote right triangles. Actually, I wrote that in the wrong spot. Let me move that down a little bit. All right, so this is going to go right here. Dang it. All right, and we'll say all right. And then lastly, wait, can you guys do this on your, sorry about that. So this is given as well. All right, so they've given us this information, and what that means is that this is congruent to this. Now, I've just proven that there are two, or I didn't prove, it was given to me. I've shown, or we're given, that the hypotenuses are congruent and that they are right angles. What else do I need to do this hypotenuse leg theorem? Yes?
AD is congruent to
I could do it that way. She said that if we could prove that AD is congruent to BC, and we've proved that before, right? In fact, that's what we did the whole last section. There's a little bit quicker way, though.
DC is congruent to DC. Because
Yeah, there you go. DC is congruent to DC. And what property is that? Does anybody here know? Reflexive. Good. So that's the reflexive property. And so since that's the reflexive property, what we found is that these two triangles are congruent based on this information. So I could just say, I could just move this over here. And this was based on the hypotenuse leg theorem. And we're just to kind of recap, are they right angles? Yep. In fact, let's go through the list. Are there right angles? Yes. Are the hypotenuses congruent? Yes. Is there a leg that's congruent? Yes. So I have a hypotenuse leg congruency between two triangles, and then I happen to know that they are right triangles.